Hello students. So far we have seen what is signal flow graph, how to obtain a signal flow graph from block diagram, Mason's gain formula for computing the transfer function of a signal flow graph. All these things we have covered and we have seen an example also to reduce the signal flow graph and get the transfer function. In this video, we will do some more examples where we will reduce the given signal flow graph and obtain the transfer function. So let's get into the session. So here's another example for signal flow graph. Now we are going to reduce the signal flow graph using Mason's gain formula and find the transfer function. So the Mason's gain formula states that transfer function is equal to pk del k, that is k varying from 1 to n divided by del. So the first job is to find how many number of forward paths are there in the signal flow graph. If you look at it, there are 6 forward paths, I should say. See here, I will go through the paths now. G1, G2, G3. This is one forward path. G1, G7, G6. 1. So this is another forward path. G1, G7, come back like this, minus H1, G8, G3, 1. So in this forward path also, every node is covered. That is, each and every node is covered only once. Not necessary that you should cover all the nodes, but we should be very careful that one node is covered only one times. Okay. So in this path, you can see that this node was covered one times, again this one times, this one time, and then this one. And it went out. Okay. So this is another forward path. The same thing will happen in the other half also, that is here G4, G8, H2 minus H2, G7, G6. So this is another forward path. Similarly G4, G5, G6. Actually the arrow mark is missing here. The arrow mark is towards this. Okay. Towards the one. So this is another forward path, and you have G4, G8, G3. So starting from here, G4, G8, G3. See, in all these forward paths, nowhere a single node was covered two times. Every forward path will lead it to the output, from the input to output. So I would like to request the students to take a pen and paper and draw all the forward paths so that you get a good hold on this signal flow graph. So the next point is to find how many number of individual loops are there. So now we have got to find del. Actually first we have to find P1, P2, P3, P4, P5, P6, and then we have to find the del, that is the common denominator del, and then move on to finding your del 1, del 2, del 3, del 4, del 5 and del 6. So if you find all these things, your transfer function is ready. So now how many loops are there? Can you guess? This is one loop. Okay, and this is another single loop, and you can see that there is another loop like 8. So I'll start like this. From this point I'll start. G7 minus H1, G8 minus H2. Okay, this is one loop. Starts from this point and ends at the same point. Okay, starts from this point and ends at the same point. So I'll come again like this. G7 minus H1. This is a jumper, there's no connection here, so this goes like this, G8 and minus H2. So there are three individual loops. Okay, there are three individual loops. So now how many non-touching loops are there? Two non-touching loops. Out of the three, two non-touching loops, it's very well seen that only this loop and this loop does not touch each other, whereas the one loop which is looking like 8, it touches both this loop and the other loop. So there is only one pair of non-touching loop. So this is one pair, this first pair, this loop along with this loop. So your gain of that particular pair will be H1 into H2 into G5 into G2. The next point will be to find how many number of sets are there, so such that three loops are non-touching. Is there three loops which are not touching each other? No. Of course, the entire number of loops is three, and they are touching each other because this is a common fellow touching both one and two. Okay, so there is no set of three non-touching loops. Okay, so there is only two terms in the del now. Other than one, there are two terms. One is sum of individual loops and another one is sum of gain products of two non-touching loops. Okay, you can see this now. So three individual loops and one pair of non-touching loop. This is one pair. Okay, there is no another set. Okay, this is only one pair is available. So with that you can compute your del. Del is 1 minus sum of all these terms, okay, plus this term. There's only one term in this two non-touching loop, so plus this term. There's no term in the three non-touching loop case, so you don't have another term here. It is 1 plus sum of these three, sorry, 1 minus sum of these three plus this element. So that is your del. Now our job is to draw a separate flow graph, signal flow graph, so that signal flow graph should not touch the first forward path, second forward path, third, fourth, fifth and sixth. So let us start with del 1. Which part of the graph is not touching the first forward path? Which one we have taken it as first forward? I think we took this one as first forward. Which part of the graph is not touching this first forward path? I think this branch is also sticking here, this is sticking here, this is sticking here. But only this loop. So you will have only these two nodes as a separate signal flow graph. So this part of the graph does not touch the first forward path. So for this part of the graph, you should apply del. When you apply del, what happens? 1 minus sum of individual loop gain. There is only one individual loop. So it is G5 into minus H1. So 1 minus minus of G5 into H1. So it becomes 1 plus G5 into H1. So I have applied to find a del 1, I have applied the formula del to only this part of the graph. That is this node and this node. Only this part. Okay. What about del 2? Which path we have taken it as the second part? Second path? I think we have taken this path G1, G7 and G6 like this. So the forward path is like this. Okay. Is there any part of the graph not touching these 1, 2, 3, 4, these nodes, these four nodes? I think all the part of the graph touches these nodes at some point of the graph. Am I right? So here there's a touch. This also gets touched with this point. This branch also, here there's a touch. So you can see that there is no part of the graph which does not touch this forward path. Similar is the case with this forward path also. G1, G7, this fellow is there. Am I right? There is no part of the graph which does not touch these nodes. Okay. By some means, see G6, it touches through this node. Okay. G5 touches through this node. G8 touches through this node. Okay. So every part of the graph touches these nodes. Okay. Which is considered to be your path 3. Similar is the case with del 4 and del 6. Only thing is you had one forward path like this. Am I right? Like this. For this path, path which is the fifth path, okay, you have one portion that does not touch this forward path. For this forward path, you have one portion. Can you guess which part? This path. Okay, this loop. These two nodes. Okay, so G2 along with minus H2. The loop gain of this particular loop is G2 into minus H2. So you have to apply del for this portion. So when you apply del for this portion, it becomes 1 minus minus G2 H2. So it is 1 plus H2 G2 del phi. So now you have got all the elements P1 to P6, del and del 1 to del 6. Simply apply all these things in the formula. So it will be like P1 into del 1 plus P2 into del 2 plus P3 into del 3 plus P4 into del 4 plus P5 into del 5 plus P6 into del 6 divided by del. So all these variables are available here now. Just you have got to substitute it here. Okay, so once you substitute, you get the transfer function. I have posted tutorial problems for this session, so kindly look into that and solve it. Okay, you have to first solve these problems which are demonstrated now. Also, again using a pen and paper, please do it in your tutorial note, and then carry out your tutorials. Okay, tutorial problems I have posted in the Microsoft Teams. So please refer to that, do it, and then post it back. Okay, thank you.